Okay, so this video is for MA 107, and we're talking about inverse functions, linear and discrete. So the question that we're given is the one-to-one function g and h are defined as follows. And we're told g of x equals negative x plus 13 all divided by 11. That's how g is defined. And then we're told h is defined as this discrete function with the points 0, 4, 3, negative 6, 7, 9, 8, negative 2, and 9, 7. So those are our two functions. Then we're asked to find the following. We're asked to find the inverse of g. That's what this raised to the negative 1 symbol means. So this is g raised to the negative 1. That stands for inverse of g. Inverse of g. And then we're asked to find the composition of g and g inverse. So this little circle dot in the middle that's there is called the composition of g and g inverse. And then finally, we're asked to find h inverse. So this is inverse of h at 9. Okay, so let's do the last one first. That's the easiest one. So let's do the last one first. Let's do h inverse evaluated at 9. And then we're supposed to figure out what that is. So we're talking about h. So we're going to look up here at h and see how that's defined. Remember, in a function ordered pair, the input is x, the output is y. So input, output. Okay, so this is h of x. That's how we would talk about h of x, as ordered pairs, input x, output y. So now for h inverse of x, well, we're talking about a new x and y, but what happened was the y from h goes in the x spot, and the x from h goes in the y spot. This is what the inverse means, right? We're inverting them. So now we have output of h, input of h. Okay? So we had h inverse relating to h, and so whatever happened in h, we inverted them. So x goes to y, y goes to x, the input goes to the output goes to the input. So when we're looking up here at h, we look at the inverse, so we're looking where the second spot is 9. The second spot is 9. Because the inverse, h inverse of 9 is right here. So the corresponding number to that, or the new output, is 7. So this answer is 7. Okay, so that's the easy one. Remember, the inverse means we're inverting. So we have put what used to be x, and the h inverse is now y. What used to be y and h, and the h inverse is now x. We inverted them. Okay, so now let's look at g. So I'm going to write down the g again down here. G of x is equal to minus x plus 13, all divided by 11. And we are asked to find the inverse. So find its inverse. So how do we do that? Well, there's a very algorithmic way to do it. Number one, where we see g of x, put a y. So y equals minus x plus 13 all divided by 11. Number two, switch x and y. Remember, we're inverting, right? So I'm going to switch x and y. So x equals minus y plus 13 all divided by 11. So notice what I did was I switched x and y. And then finally, solve for y. So I have x equals negative y plus 13 all divided by 11. So I'm solving this for y, so multiply both sides by 11. So I have 11 times x is equal to negative y plus 13. Then I subtract 13 from both sides. So I have 11x minus 13 equals negative y. And then I want to multiply both sides by negative 1 to solve for y. So I have negative 1 times x minus 13 equals y. And if I distribute that, I have negative 11x plus 13 is equal to y. So this then is my g inverse. So that's often the fourth step. Rename g inverse. So g inverse of x is equal to minus 11x plus 13. So that would be the answer to how to find this g inverse of x. Now, the theory goes that the inverse composed with the original function, or the original function composed with the inverse, will reproduce whatever you put in. So in other words, the way we actually write this out is that g composed with g inverse of x is equal to the same as g inverse composed with g of x, and those are equal to x. So let's give that a try. G composed with g inverse of x equals, well, g is minus x, so minus and then g inverse plus 13 all divided by 11. And then I put minus, what's g inverse? Minus 11x plus 13. And then plus 13 all divided by 11. And so when I distribute the negative, I get 11x minus 13 plus 13 all divided by 11. And sure enough, that will simplify to just x. So that's g composed with g inverse. So now let's try it the other way around. So g inverse of composed with g of x, well, g inverse was minus 11, and then now g plus 13. So that would be minus 11 times g, which was minus x plus 13 divided by 11, and then plus 13. So if I distribute this negative 11 inside the bracket, this 11 and this 11 will cancel. And so I get negative x plus 13, and then plus 13. So when I distribute, I get x minus 13 plus 13. And sure enough, that's also equal to x. So that way I know for sure that I have the correct inverse, because the rule says that an inverse composed with the original function, or the original function composed with the inverse, will always simplify to x. And so when we look at this last problem that they're asking us to do, find g composed with g inverse of 1, well, using that rule, if they are truly inverses of each other, whatever value I put here is what I'm going to get out. And so this would equal to 1. So I don't really have to do any more than that. Just understand that that concept means that the inverse composed with the original function, whatever you put in is what you're going to get out, or the original function composed with this inverse, whatever you put in is what you're going to get out. Okay, I hope that helps. Let me know if you have any questions.